Good morning, one and all. Today we are going to see chapter number first, crystal structure. In this chapter, we will see introduction to crystal physics, crystalline and non-crystalline solids, space lattice, crystal structure, lattice parameters, crystal systems, and Bravas lattice. Friends, in the introductory part, we have to see introduction to crystal physics. We know that matter is divided it into three parts such as gases, liquid and liquid crystals, and third one is solids. Then question will be arise, what is crystal physics? Physical properties of crystalline solids, determination of their actual structure by using X-rays, neutron beams and electron beams. We will see classification of solids. Solid materials are divided in the following types such as crystalline. In crystalline solids, that is again divide it into the single crystal. Polycrystalline solid is divided into the amorphous solid, and this is also called as non-crystalline solid. And these are the examples of the materials. Now, in crystalline solids, we have to see the arrangement of the solid. In that, arrangement of the units of matter is regular and periodic. Anisotropic substances, sharp melting point, possesses a regular shape. Example, iron, copper, carbon, German, etc. Now, we have to see non-crystalline solid, that is amorphous solid. Particles are randomly distributed, isotropic in nature or isotropic substances. Non-crystalline solids have wide range of melting point. Examples are glass, plastics, rubber, etc. Now, polycrystalline solid, aggregate of many small single crystals, high degree of order over many atomic or molecular dimensions, grain boundaries. Grains are usually 100 nanometers to 100 microns in diameter. Polycrystals with grains less than 10 nanometers in diameter are nanocrystalline. The examples of polycrystalline solids are inorganic solids, most of the metals and ceramics, etc. Now we have to see the crystallographic terms. In crystallographic terms, first point is space lattice, lattice points, lattice lines, lattice planes, basis or motif, crystal structure, unit cell, and lattice parameters. First of all, we have to see space lattice. The regular and periodic arrangement of points in a three dimension or the identical surroundings to that of every other point in the array is called as the space lattice. In figure, we have to see the periodic arrangement of the dots, and this is called as the regular and periodic arrangement of the points in the three dimensions. If we have to consider the point P, then from the point P at the left hand side we have to observe the periodic and regular arrangement, as well as in the upper side we have to again observe the periodic and regular arrangement, and now therefore these are the every point is identical to the surrounding points. Now the second important point is that is basis. Basis is a unit assembly of atoms or molecules identical in composition or arrangement and orientation. Or basis is again defined as the repetition of basis correct periodically in all direction. The crystal structure is real while the lattice is imaginary. This is the important point. Again, all of you listen it. The crystal structure is real while the lattice is the imaginary point. Suppose we will see some examples and number of atoms in the basis. Suppose aluminium, then number of atoms in the basis is 1. Barium, number of atoms in a basis is 1. NaCl, number of atoms in the basis are 2. KCl, number of atoms in the basis are 2. CaF2, number of atoms in the basis are 3, etc. Friends, the interesting thing is that is the crystal structure. Now, what is the combination? Which combination is made the crystal structure? The crystal structure is equals to lattice structure plus basis, or lattice plus basis is equals to crystal structure. This figure shows the lattice structure in the first figure with the help of the blue color dot. With the help of the red color dot, we have to show here the basis, and whenever there is a combination of the lattice structure plus basis, we will see there is a crystal structure is formed. Now, after that, the important quantity is in the crystal structure are unit cell. Unit cell is nothing but a fundamental building block, or repeating its own dimensions in various directions gives the crystal structure. These are the figures. Here the fundamental building blocks are observed in the repeating manner. Suppose in middle figure we have to observe carefully, then we observe that there are the unit cells are observed at the left hand side, right hand side, at the upper side, at the lower side. In this way, there is the fundamental building blocks are arranged in a repeating manner in a own dimensions in a various directions, and this is called as the unit cell. Now, after that, we have to see the lattice parameter. While observing the lattice parameter, we have to consider the figure. In this figure, there is a cube and x, y and z are the crystallographic axes of the cube. The length of the unit cell along the x, y and z direction are A, B and C. Now, whenever we are going to see this figure, then there are the interaxial angles are made, that is alpha, beta and gamma, where alpha is the angle between A and B, beta is the angle between B and C, gamma is the angle between the C and A, and alpha, beta, gamma are known as the lattice parameters. After that, the important cell is there, that is called as the primitive cell. Here we have to see the figure 1, that is the primitive cell, figure 2, that is the body centered cubic structure, figure 3, side centered cubic structure, and figure 4, that is the face centered cubic structure. Now, what do you mean by primitive cell? A unit cell consists of only one full atom is known as primitive cell. A primitive cell got the points or atoms only in the corners. If a unit cell consists of more than one atom, then it is not a primitive cell. Example for primitive cell, simple cubic structure, that is SC. Example for non-primitive cell, that is the BCC and FCC unit cell. Now, there are 7 crystal systems in the crystal structure, such as cubic structure, crystal structure. After that, trigonal, then orthorhombic, then rhombohedral, then hexagonal, then monoclinic, and after that triclinic. These are the 7 important crystal systems. In these 7 important crystal systems, these crystal systems are important because whenever we have to interested to find out the dimensions of the unit cell specified by the three sides, that is A, B, C, and corresponding angles, that is the alpha, beta, and gamma. These are depending upon the sides A, B, C, and alpha, beta, and gamma. Then the 7 basic types of lattice structures are found in the 3-dimensional structure, and so that these are important. We have to see the one by one. Whenever there is the particular crystal system is there, then its length of unit cell is different. Also, the interaxial angles are different, and the number of lattices in the system are also different. We have to see one by one. First of all, we have to take the cubic structure. In cubic structure, A is equals to B is equals to C. Now, but the angle is alpha is equals to beta is equals to gamma, and that is equals to 90 degree. Now, the example of the Bravas lattice is the simple cubic structure, and the number of lattices in these systems are 3. Second crystal system is tetragonal system. In tetragonal system, the axial length of the unit cell is A is equals to B is not equals to C, and the axial angles are alpha is equals to beta is equals to gamma is equals to 90 degree, and the number of lattice in the system is equals to 2. Next system is orthorhombic system. In orthorhombic systems, axial angle A is not equals to B is not equals to C, that is shown in the figure. Now, the interaxial angles are alpha is equals to beta is equals to gamma is equals to 90 degree, and the number of lattices are 4. Next crystal system is monoclinic system. In monoclinic system, the axial length of the unit cell A is not equals to B is not equals to C, and the angles are observed, that is alpha is equals to beta is equals to 90 degree is not equals to gamma, and the lattices are 2. Triclinic system considered A is not equals to B is not equals to C, and alpha is not equals to beta is not equals to gamma is not equals to 90 degree, and the number of lattice in the system is 1. Next system is trigonal system. In trigonal system, axial length of unit cell A is equals to B is equals to C, and lattice axial angles alpha is equals to beta is equals to gamma is less than 120 degree is not equals to 90 degree, and the lattice number is 1. Last system is hexagonal system. In hexagonal system, A is equals to B is not equals to C, and the interaxial angles are observed, that is alpha is equals to beta is equals to 90 degree and gamma is equals to 120 degree, and the one number of lattice are observed in this particular system. Now there are the different Bravas lattices are there. These Bravas lattices are shown in this figure, that is there are total 14 Bravas lattices are there under the 7 systems, that is the simple cubic, face centered cubic, body centered cubic, simple tetragonal, body centered tetragonal, hexagonal, simple orthorhombic, body center orthorhombic, base center orthorhombic, rhombohedral, simple monoclinic, base center monoclinic. We have to see one by one. Now, in simple cubic structure, that is the basic system is cubic system where A is equals to B is equals to C and alpha is equals to beta is equals to gamma is equals to 90 degree. Now, this is examples are Fe, Ag and Cu. Now, second is the body centered cubic structure. Body centered cubic structure is belonging with the cubic structure in that A is equals to B is equals to C and alpha is equals to beta is equals to gamma is equals to 90 degree, and the examples are NaCl and Na. The third cubic structure is face-centered cubic structure. In face-centered cubic structure, there are A is equals to B is equals to C and alpha is equals to beta is equals to gamma, that is equals to 90 degree, and the example is CSCl. Now next one is tetragonal basic system. In tetragonal basic system, there are only two crystal structures are there. Simple tetragonal. In simple tetragonal, A is equals to B is not equals to C and alpha is equals to beta. Alpha is equals to beta is equals to gamma is equals to 90 degree, and examples are bismuth, SN1, NiSO4. Second crystal structure in the tetragonal system is body center tetragonal and example is TiO2. The next system is orthorhombic. In orthorhombic system, simple orthorhombic crystal structure is observed where A is not equals to B is not equals to C. Example is Ga. Second crystal structure in this system is body center orthorhombic where alpha is equals to beta is equals to gamma is equals to 90 degree, and Fe3C is the example. Face center orthorhombic is also belonging to this system in which alpha is equals to beta is equals to gamma is equals to 90 degree, and cementite is the example of this crystal structure. Side center orthorhombic crystal structure is observed in this system. Now next one is the trigonal, or this is also called as the rhombohedral crystal system, in that A is equals to B is equals to C where alpha is equals to beta is equals to gamma is not equals to 90 degree, and this is the simple primitive crystal structure. Examples are calcite, arsenic, Sb and Si. Now next one is the hexagonal system. In hexagonal crystal system, A is equals to B is not equals to C and alpha is equals to beta is equals to 90 degree and gamma is equals to 120 degree. It is simple primitive structure. SiO2, Mg, Zn and Cd, these are the examples. In monoclinic cluster system, A is not equals to B is not equals to C, alpha is equals to gamma is equals to 90 degree, not equals to beta, and example is 2H2O CaSO4. In this system, side center cubic structure is also there. Example is gypsum. And the last system is there, that is triclinic system where A is not equals to B is not equals to C and alpha is not equals to beta not equals to gamma, and that is equals to 90 degree. Example is CuSO4. These are the 14 systems belonging to the 7 crystal structures. Now from that we have to make the another table of the bravas lattices, divided it into the 7 crystal systems, that is the crystal system shape of the crystal system and the Bravas lattices. Cubic crystal system, shape cube. It is the primitive